Okay, question 7 starts us off by asking us to find a discriminant. Okay, so I think most of you know that that means b squared minus something. Okay, and we need an a, b and a c, so it's quite good to just look at this equation and think, okay, here's our b, here's our c, and here's a. Okay, the number in front of the x squared. A, b and c never involve x's. So they can involve k's, but this b, for example, is just the bracket k plus 3. It's not k plus 3 times x. Okay, so having worked out your a, b and c, then it's b squared minus blah de blah de blah, so it's bracket squared minus 4 times bracket. Fill in the brackets correctly. You might as well simplify because in the next part you're going to need to do something with this. Part b is just completing the square. So this answer you've got here has got k squareds in it, it's got k's, and all you have to do is complete the square on this. So I think you're all good enough to complete the square once you have got a correct answer for this and you've multiplied it out. But some of you didn't really realise it was completing the square, I don't think. Okay, so simplify what you got here, complete the square. Hardly anyone got part C right. Okay, and that's because we're using the completed square form in a slightly different way from normal. Okay, it doesn't mention thinking about a graph at all, but you know that the numbers here and here tell you the vertex of the graph of this thing. Okay, and because of the numbers you get, b turns out to be a positive number. So if you actually imagine sketching the graph of this, you'll be able to do a rough sketch. You'll be able to tell me the coordinates of that point. But because b is a positive number, the y-coordinate is positive, you can argue that the vertex of this graph here, okay, is up above the x-axis. Well, what does that mean? It means that this thing here is always in the y is greater than 0 section. It's always positive. So if the discriminant's always positive, okay, this is the trigger thing. You know that this is what tells you need to think about a positive discriminant, but we've been working with that discriminant all the way along. So the discriminant you worked out in part A, we want to show is positive, and the form we put the discriminant into in part B, okay, we can argue by thinking about a suitable graph, we can argue from that graph that the discriminant is always positive. Now this was the hardest 2 marks on the test, but hopefully if you drop those 2 marks, as most people did, that explanation will enable you, just a graph and an argument from this graph will enable you to explain why the discriminant you found in A is always positive. See how you get on with that.